Hi, my name is Daphne Koller and I'm a professor at Stanford University. Today I'd like to invite you to my class on probabilistic graphical models. Probabilistic graphical models might sound like a bit of a mouthful, but they're actually really cool because they're a general framework that builds on ideas from statistics and probability theory on the one hand, that's the probabilistic, and ideas from computer science on the other hand, that's the graphical models, to solve really hard problems that involve lots of variables that we're uncertain about. So what are some examples of that? Probably the earliest application of probabilistic graphical models within computer science was in the area of medical diagnosis. Here we want to get a computer to help a doctor diagnose a patient. Now why is that hard? Because there are a lot of different sources of evidence and things that we care about, and all of them are a bit noisy and uncertain. Predisposing factors, symptoms, test results, different diseases that the patient might have, and different outcomes to treatments that we might try out. A very different application that is in common use today is in the area of computer vision. Here we might have an image such as this and we'd like to figure out what's in it. So we'd like to label, for example, different regions of the image as representing different semantic categories: car, road, sky, tree, and so on. Why is this hard? It's not hard for humans, but it's hard for computers because there's lots and lots of pixels, each of which needs to be labeled, and the computer is not really good at looking at a pixel and figuring out what it belongs to. So what does a graphical model look like? It takes all of these different things that we're uncertain about and tries to show how they relate to each other. So this, for example, is a baby model for medical diagnosis that includes things like predisposing factors, diseases, and test results and symptoms. Of course, a real graphical model doesn't look like that. It looks a lot more like this, so much more interesting. What will this course teach you? We'll talk about the framework of graphical models and what they look like. We'll describe different kinds of algorithms that can use such a model to answer different types of queries. And we'll talk about how one might construct a graphical model by combining information from a domain expert, as well as using machine learning from historical data. It turns out that this framework has an enormous number of applications, some of which we'll touch on during the course. In addition to the ones that we've talked about, there's applications in natural language processing, in computer communication and satellite communication, in speech recognition, in robotics, and others. What will this course consist of? The material will be presented in video format in a set of short modules, each of which represents a coherent concept. Those videos will be accompanied by quizzes that will give you instant feedback as to whether you're understanding the material or not. Finally, we'll have a set of programming assignments that will be automatically graded, and these will be kind of cool because many of them are based on real-world applications, so they'll demonstrate the real-world applicability of the techniques that we learn in class. At the end of this course, you'll have acquired a set of tools that will allow you to deal with the kinds of hard problems that you care about and solve problems that you might encounter in your life. I hope to see you in January.